Hello, everyone. Welcome to Community Office Hours for Consul. It's a special edition this week. If you haven't heard, KubeCon Europe is happening. And for those who are not going to KubeCon Europe, we're glad you're tuning in here. If you're at KubeCon Europe and you're tuning in anyway, we also appreciate the time that you're taking to tune into us here. But we do have some folks on the ground at KubeCon Europe. So if you're interested, let us know and we'll let you know who they are and where you can find them. I'm your host, Rosemary Wang, and we're going to have an open Q&A with the Consul on Kubernetes team. Well, just one person from the Consul on Kubernetes team, but it's very exciting nevertheless. And I know that a couple of them may be lurking in chat, which we appreciate as well. Today is everything about Consul on Kubernetes. We're focusing specifically on Consul on Kubernetes with Vault and maybe Federation involved. We'll see what happens. But we're really going to just focus on your questions. And if you have any specific inquiries or comments about Consul on Kubernetes, please interact with us in chat. Drop a note in there. We'd love to hear from you, whether you're on YouTube or LinkedIn tuning in. As you do, please keep in mind our code of conduct in this virtual space. In general, we ask that you be welcoming, inclusive, friendly, and patient, be considerate, respectful, and professional. You can review our code of conduct at hashicorp.com/community-guidelines. I'll be sure to include that on the screen. Now, if you have any questions, just drop it in the chat. We have Kyle here today, who's going to show us some awesome stuff for Consul and Kubernetes in particular. Kyle, could you introduce yourself to the audience?
Yeah, thanks, Rosemary. I'm Kyle Schochenmaier. I am an engineer on the Consul on Kubernetes team. So we focus on enabling Consul to run in various Kubernetes platforms and clouds. And today I'm going to talk a little bit about one of our more recent integrations. So that integration is the ability to use Vault as a secrets backend for Consul on Kubernetes. And so what that'll do is allow your Consul installation to move its secrets, like its TLS certificates, its encryption keys, that sort of stuff, up into Vault, where you can have that as a single plane of management for your secrets.
Awesome. I guess we should start from the beginning for those who are not as familiar with how you run Consul on Kubernetes. We have a Helm chart available. You can customize how you're going to deploy Consul on Kubernetes with the Helm chart values. So if you haven't explored that yet, check it out. Vault is the same way. You'll see Kyle deploy Vault using a Helm chart as well. So if you're interested in learning more, we also have some other content, but we're going to kind of scooch right past that. We're going to talk about something really cool, and I think we should probably describe a couple things about Consul and why you would set up Vault as a secrets backend, right, Kyle? So why would you use Vault as a secrets backend for Consul in the first place?
So a lot of companies. So first off, there's multiple reasons. One great one is that a lot of companies are starting to have compliance requirements that mandate that they store privileged information like your encryption keys or your TLS certificates in a secure location. And for a lot of companies, not all of them, but for a lot of companies, those compliance requirements actually say you can't use Kubernetes secrets anymore. And so what we've done is we've said, all right, well, if we can't use Kubernetes secrets, what's the next best thing? And that would be Vault. The second piece is that Vault actually can issue your TLS certificates for you. So instead of having Consul manage and issue all of those, Vault can be a certificate authority and issue all of your certificates for you. And then you can have the management of that be actually done through your Vault administrator, who's more familiar with the management of secrets, TLS certificates, than maybe a Consul administrator or a Consul dev might be.
Cool. There's actually an interesting comment in the chat, and I do want to address this. It's yes, there may be a circular dependency, right? Vault will depend on Consul, then Consul will also depend on Vault. Is that kind of risky? In sort of previous architecture, Vault did have a Consul storage backend. If you are doing this and you are using Vault with the Consul storage backend, you may want to separate the Consul cluster that you're using as a storage backend for Vault from your Consul service mesh. This is a general rule of thumb. However, we do not recommend you necessarily run Vault with a Consul storage backend anymore. We highly recommend you use the integrated storage backend in Vault. So that's using Raft. So you do not have to depend on Consul anymore, and you eliminate the circular dependency. But if you do want to run Consul as a storage backend for Vault, just make sure they're two separate clusters, that your service mesh cluster that would depend on this Vault secrets backend would not be the same Consul cluster that you're using to be a storage backend for Vault. So just eliminate that circular dependency. Kyle, any other comment or color that you want to add to that?
No, actually, you did a great job with that. It's really just, I would consider them possibly separate pieces of infrastructure. If you're gonna, you have Vault with Consul behind it as a different piece of infrastructure from your service mesh, just like the way you mentioned it. So yeah, definitely keep those separate. But we do recommend to use the integrated Raft storage for Vault now.
Yeah, definitely. And one other comment before we move to the demo, some of us may not be ready to make the leap and run Vault and would like to run Vault outside of Kubernetes. And in which case, can Consul on Kubernetes use an external Vault as a secrets backend?
Yeah, it can. When we get into kind of the configuration phase of the demo, we have built it out in a way that you can specify, or that you have to specify, an external or internal location for your Vault server. So that can be external, that could be internal to the Kubernetes cluster. It just needs to be a Vault API that we can hit from our Consul on Kubernetes installation.
Awesome. Cool. I think that's the last question we have for now. Kai, would you like to show us this demo, this mythical thing about Consul, Vault? And there are a couple secrets in Consul that you can manage in Vault, so we're going to walk through some of those as well.
Yeah, definitely. So essentially what I'm going to show is kind of a day one approach to setting this up. And so what that means is installing first a Vault server along with the agent injector, which I'll get to in a second. And then I'm going to install a installation of Consul on Kubernetes. These are both going to end up in the same kind cluster, just for simplicity's sake and to hopefully appease the demo gods. We're just going to keep it simple and just put them both in the same cluster. So, but we just had that great question. We could set this up where it would be an external Vault installation, or in the case of Federation, it would be an external Vault installation. But yeah, I'll just go ahead and get started. So I have here in the top, I hope everybody can see the screen.
Yeah, I think we're okay for now.
Cool. So I just have a simple kind cluster here. I just deleted it and reinstalled it, so there's nothing on here other than the normal stuff. And then what I'm going to do is just basically start by installing the Vault data center. And so for simplicity's sake, what I'm going to do is install the dev server. So that's not using the Raft backend that we talked about. This is just using an in-memory database. So if we were to lose this node or lose this pod, it'd be gone forever. But that's just to avoid having to set up the server and unseal and init and all that other jazz. But the only thing that really needs to be added here is setting up the injector. And so what we're going to do is install the Vault agent injector. And what the Vault agent injector does is it is a webhook that is going to intercept deployments and pods, read their annotations, and possibly decide to inject Vault secrets into those pods. And I can show you when we get to the Consul installation where that actually is being, where that's actually coming from in the Consul deployments. But let me just go ahead and get the Vault installation setup here. So I'm just going to do Helm install, and this is just going to use the latest and greatest Vault Vault Helm chart. And then down here, I'm just going to show that the pods are being attached, or I'm sorry, that the pods are starting up. Okay. And there. So now we have our Vault installation. And what I'm just going to do is port forward to that Vault server so that I can open up a web browser and show kind of what's going on in the background on Vault. So bear with me just a second as I bring a tab over here. So if I go to localhost 8200, then I'm going to have the UI for Vault here. And since it's a dev server, the password is just root. And as you can see, we just have like a basic, completely vanilla installation of Vault here with nothing set up yet. So the next thing that we need to do is actually set up Vault before we install Consul. So just to give us an idea of what the Consul installation needs, I'll open up the Consul values file. So over here, in order to configure Vault, we have to set up a stanza. I'm sorry, in order to configure Consul, we have to set up a stanza in the Consul values.yaml file. And that stanza is the secrets backend Vault stanza. And that's going to contain references to the Vault auth methods and roles and policies and secrets that Consul is going to use to fetch from Vault. So I'm just going to walk us through how we actually generate these in Vault and then install Consul afterwards. So what I will do is open up a script. So I just wrote a simple script here, which bootstraps Vault with all of this information, because it's actually quite a few commands. So easier to do this via a script than fat finger it in front of everybody.
Or as a note for folks who are curious, you can do this set this up with Terraform. So you can configure Vault with Terraform as well if you want. So all of this you see here, you can make the equivalences in your favorite automation tool.
Yes, thank you. Just for this script, we're doing some basic environment variable setup here so that we can issue Vault commands directly to Vault from my laptop. What we need to do first is set up a Vault auth method. And so what this does is it allows the Consul service accounts to talk to Vault, get tokens, and make requests against secrets. So that's just basically setting up an auth method path called Kubernetes DC1. And we actually have that indicated over here in the Consul installation. In the Consul values.yaml file. The next thing that we actually need to do is then set up all the auth roles. And so these actually bind a Consul service account to a list of policies that we'll see in just a second. And these policies are basically ACL policies that provide permissions against secrets. So for the Consul server here, we have a Consul server role over here. This is going to need access to Bootstrap token, gossip key, connect CA, RT. This is our service mesh certificates, and this is our TLS certificates for the servers. Similarly, we have additional ones for the Consul client. We have one for the ACL initialization job, and we have one more for the service mesh certificates. I'm sorry, this is not for the service mesh certificates. This is for the CA cert for all of our other components. Next, after all of that is set up, what we have to do is set up the gossip encryption key. So this is one of the configurables that you can set inside of Consul, and this controls the encryption that is run on the gossip protocol between the Consul servers and the Consul clients. And so we actually specify that in the gossip encryption stanza. This is the same stanza that was here before the Vault integration. So it's nothing new. This is just now referencing a Vault path instead of a traditional Kubernetes secret path. So in this case, we're just having Consul keygen generate a key for us, and then writing that into the secret and creating a policy that allows us to read that. I apologize for the UI port forwarding getting all over the top of my script. I hope it is still readable. So now that we have the gossip encryption key set up, we can set up the TLS certificates. So this is the TLS certs that are going to be used by the server. So we have to set up a root CA and then create a role for the PKI certificate engine, and then specify a few fields here. And one of them is the DNS SANs. So these have to line up with the server's DNS entries when we install Consul. It's just really just DC1, and then all of these other pieces are standard. So whichever DC that you would be installing, it's just DC1 or DC2, and then the same command here. Then we just create a policy, which will allow the Consul servers to actually request Vault to issue certificates. So when the servers come online, they're going to say, please give me this path. That path is right here, the server cert. Please issue me a certificate at this path using our annotations, which I'll get to in a second. And then it will issue a certificate to the server, and then load that into the Consul server pod as well. And then the CA certificate is also another policy that our components need read access to. The Bootstrap token is another configurable. And so what this does is it says we're loading a secret into Vault, and then we're going to tell Consul to use that UUID as the Bootstrap token. So it allows you to control that. Previously, you didn't really have very much control over what the Bootstrap token actually is. So you can set that now, and then reference it in Vault, manage it from Vault, and that will actually bootstrap all of the ACL tokens that are in this Consul installation. Finally, the last piece is configuring the Connect CA. And so this is the service mesh certificates that are being used for our mesh traffic. So in order to do this, it's a pretty complicated policy that we're writing. This is just a straight rip out of the docs for setting up the Connect CA with Vault. So you can just copy paste it out of the documentation, and you just need to specify the correct path. So in this case, we're setting up a root PKI path, which corresponds up here. We are setting up a intermediate PKI path, and we've already set up the auth method. And this actually is where, if we go back to the first question, this is actually where you would set up an external Vault address. So if your Vault address were in a cluster virtual machine somewhere else, this is where you would provide the access to that, either through a DNS name or an IP address. So that is all of the configuration to get it up and running. Pause for questions or just go ahead and run it. What do you think, Rosemary?
So I think it's good to just, for those who are not as familiar with Vault and not as familiar with Consul at the same time, so in Vault, there are secrets engines, right? And so you need to set up a secrets engine to produce a secret. That's the idea. Consul has a couple sets of secrets, right? I think you showed ACLs and gossip encryption, the gossip encryption key. Both of those are static secrets, right? You can't just use a dynamic secrets engine and auto rotate them, because Vault has the ability to do auto rotation if you set up a dynamic secrets engine. But those two are not using dynamic. They're using key value.
They are, yeah, they're using the KV2 secrets engine. So just regular key value. That's correct.
Yeah, so they're static. So you would have to load them in, and that's what Kyle's doing here. And then the certificates are using one of the dynamic secrets engine, and that's what we call the PKI secrets engine. And in that situation, Vault would rotate those certificates for you.
Yes, that's correct. So a little bit of background here on that specifically is we have the Vault agent injector here, and that Vault agent injector is going to add a sidecar to each one of our console components when we actually install. And that sidecar is going to be responsible for ensuring that the secrets are up to date in the pod with what is in Vault. And so what that means is, especially for dynamic secrets like the TLS certificates, when those are approaching expiration, the agent sidecar is going to go and ask Vault to reissue a new certificate. And when it does that, it's going to load a new certificate onto disk, or onto the pod, sorry, and place that in place on the servers. By default, a new feature of Consul 1.12 is that Consul will actually then go ahead and automatically rotate those TLS certificates into use.
Yeah. So that's basically like zero downtime certificate rotation, effectively.
Yep, exactly.
Completely automated, which is really nice, because if you ever have to rotate your service mesh certificate, that's like I guess a day 365 sort of concern.
I think the default is 720 days, but yes, day 720. Yeah.
Yeah, day 720. You wouldn't otherwise do it. And then like 2 years later or so, you're like, oh no, it rotated and everything's broken and none of my services connect. So if you set this up, at least it's automatically rotating it for you. And one other thing to clarify for folks who are not as familiar with Consul, there's two sets of certificates, right, Kyle? So there's one for the service mesh and there's one for the cluster operation itself. So the cluster operations can be secured by a TLS certificate. And then there's also the service mesh itself that's secured by a separate certificate, correct?
Yes, correct. So the service mesh certificates are the, I guess we've documented it as the Vault Connect CA. So that's the certificate authority for using Vault for Connect. And so Connect is our service mesh. The server certificates, which are the ones that are being used for the components to talk, are the ones that are being used between like the server and the clients.
Awesome. Okay. I think we're good to run it now. I just wanted to make sure we were clear on all the permutations of certificates.
Yeah, definitely. And also there are ways to rotate the other, the non-dynamic, the static secrets. But those are just more manual. Wherever we have those processes already documented, the same would apply. It's just being stored in Vault now instead of inside of a Kubernetes secret.
Got it. And would that mean, so for example, like maybe the Bootstrap token, you wouldn't necessarily rotate, you would sort of deprecate for some reason. I don't know, maybe you would rotate the Bootstrap token, but more likely is maybe the gossip encryption key. Does that mean that you have to redeploy Consul in order for Consul to pick up the new gossip encryption key, or would the Vault agent injector handle that as well?
So the agent injector would actually update that. So if you were to just go and change that in Vault, it would update on the pods. And then what you would need to do is just do a kind of day two process of updating the key rings manually. That one's a little bit of a challenging process at scale, because there's just, you want to ensure that you're doing it when the system is stable, so that everybody gets the gossip encryption key is really encrypting everything, all the RPCs and between these servers and clients. So you want to make sure that you do that at a stable time. But yes, you would just update that, and that would automatically be reflected inside of the Consul pods. And then you can go ahead and update your key ring inside of those servers. Yeah.
Awesome. Okay. Yeah. So anybody who is watching this, if you're trying to rotate the Bootstrap token or the gossip encryption key, when you do it in Vault, you have to make sure to do a second manual step as well in the Consul cluster itself. So just make sure you're doing that. Yeah. And as a note, someone did ask if there's a repo that you can check to reproduce the setup. There is a link to a repository. It's not, I guess, Kyle, it's not exactly the local cluster capability you're using, but it is available.
Yes. I have a repo. I think I sent the link to you a little bit earlier. That one's actually a repository that in addition to what we're doing in this demo, is actually sets up federation between two clusters. I didn't have time to prepare that for this demo, but it does work. I ran it this morning. So you can use this repository to set up federation between two Consul Kubernetes clusters with Vault as a secrets backend.
Cool. All right. And I put the link in the chat as well as on screen. So if you're interested in reproducing, there it is.
Awesome.
Okay.
All right. And we'll just go ahead and I walked us through this script a little bit ago, and I'm just going to go ahead and run it. It's fairly quick. Boom, done. Magic. So now if we actually were to go and look inside of Vault, it's probably going to kick me out again. It always does. Now we'll see that we've actually set up the secrets. Oops, I always clicked the wrong one. Consul secrets, Bootstrap token, and gossip encryption key. So you could see that like this is the encryption key we're going to use when we actually install Consul. Then also the PKI engine is set up as well. So this is going to be the issuing path that our servers are going to use to generate or to request certificates to be issued. Once I actually install, those certificates will be issued, and then we could probably see them updated in here as well. Also, the auth method has been created for DC1. So this is that auth method that each of those components that we set up are going to use to fetch Vault tokens and fetch their secrets. And over here, I'm just going to now helm install Consul DC. Let's see, helm install. Sorry, I have the wrong screen pulled up on this one. There we go. So now we can do helm install Consul DC1 with the values.yaml file that we just provided. And what we're going to see here is the Consul component pods. So that's the server, the clients, the connect injector, and the controller actually are being injected with a sidecar from Vault. And that sidecar from Vault, as I mentioned earlier, is going to be responsible for ensuring that the secrets stay up to date in the pods with what is actually inside of Vault itself. So it's going to periodically double check that everything is still valid. There's also an init container that is attached, which is responsible for actually initially fetching all of those secrets. And it's just coming online, and voila, it is online. Cool. So just a little bit of background. What is actually happening here is I'm going to describe this pod, the server pod. There we go. What's actually happening is our Helm chart is adding some annotations for the Vault injector to parse. And these are what are actually responsible for injecting those secrets that we referenced in our values.yaml. And so through these annotations, it's going to keep it's going to put our secrets in the right format. It's going to issue the certificates with the right names. It's a bit hard to read. Sorry, I don't normally operate with text this large. But this is essentially what is driving all of the certificate logic in the background, all of the secrets logic in the background. Excellent. Let's see. I don't know if there's anything exciting that I can show you in the Vault UI, but in the Vault UI, you can actually look at the service mesh certificates and see that one was issued. So this is what was issued after we installed. We can see that we have our auth methods have been populated with new tokens. The PKI engine has certificates as well. These are for the various components, the servers and the clients. Yeah, can I answer any questions or
Yeah.
help
So
out any other way?
Yeah. So, is there anything else that you can? So there, we went. I guess effectively, it's you've shown 4 secrets, right? So
Mhm.
that's ACL, Bootstrap token, gossip encryption key, certificate for cluster, and certificate for service mesh. Are there
Mhm.
other secrets that you could store in Vault and retrieve them and use them to create a console cluster?
Yeah, actually, you can now, as of the 1.12 console release, we now have moved all of our secrets from Kubernetes secrets into Vault. So there is the option to set those up. That's going to be sync catalog, the replication token, the Bootstrap token. We overhauled our ACL tokens and the logic for creating those as well. I'm blanking on the rest of the tokens off the top of my head, but I do know that we did actually set up support for all of the Kubernetes tokens.
Nice. And previously, the console Helm chart created, not the console Helm chart, but console creates I guess the software that, the controller almost that runs and sort of drives the initial bootstrapping of console cluster, created Kubernetes secrets. And some of those Kubernetes secrets had like ACL tokens, for example.
Mhm.
Are those still managed by Kubernetes secrets, or are they stored in Vault somewhere as well?
So they're not actually stored. The only 2 ACL tokens that are stored in Vault are the Bootstrap token and the replication token.
Mhm.
Previously, Consul on Kubernetes would actually run a job at installation time that would create all of those ACL tokens for all of the components and store those inside of Kubernetes secrets. And what we've done now is actually remove that process in the sense that we no longer actually create ACL tokens for those components at startup. Those are created using the Kubernetes auth method now at startup. So when the controller comes online, it actually makes a request to the console server that says, please issue me an ACL token. And then it destroys it when it shuts down. So there's no longer any long-lived ACL tokens that are stored in Kubernetes secrets.
Cool.
That their life cycle follows their pods now.
Nice. Very cool. So that means you cannot use and someone can't just retrieve a console ACL token and access like certain information in console right anymore using a Kubernetes secret.
Exactly. Now, if you wanted to do the traditional, like log into a console server and use an ACL token to issue a command, what you would be doing is issuing that using an ACL token that you've either created or using, like a lot of our docs say, to use the Bootstrap token. Well, now the Bootstrap token is stored in Vault, so you'd have to just use that secret that's in Vault, and that would be sufficient to be able to run your commands inside of the console pods.
Yeah. You could audit who's using the Bootstrap token based on who's retrieving it from Vault.
Yeah, actually, and that's another thing that thanks for mentioning that. That's a great point for why you might want to use Vault as a secrets backend for console here, is that you do have auditing of when your certificates were rotated. You have auditing of when people are taking your Bootstrap token and using it, right? Whereas previously, you'd have to, if you're lucky, go search through logs somewhere uh, and hope that you can find that.
The question was which logs. I don't even know which logs I would start looking
Actually,
in.
yeah, I don't know off the top of my head.
So I guess the other question, that some folks may have is that what happens if you're using something like HCP Vault or a console server that's not a set of console servers that's not running in Kubernetes? This means that some of these don't apply. Some of these parameters don't apply, for example, right? Like gossip encryption key, Bootstrap token, because you're setting them outside of the Kubernetes cluster.
Mhm.
That has to be done manually. But what about certificates, specifically the service mesh certificate? If I still wanted Vault to manage the service mesh certificate, and I
Mhm.
wanted it to do this for a Consul server that's being deployed outside of Kubernetes with clients in Kubernetes, is that possible to do?
That is a good question, and I'm blanking on that. I'm sorry.
Yeah. No. I assume
So
there's an API where all of this is happening where you can bring your own certificate, right? So you would have to
yeah,
use the API, I guess, create similar to what Kyle did. I guess you would have to create the certificate, set up, configure the PKI secrets engine in Vault, and then use the Consul API to pass this, bring your own certificate, so to speak, I guess.
correct. Yeah.
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 So it wouldn't handle the auto rotation necessarily. So that's kind of what's nice about it being in Kubernetes as well. It handles auto rotation.
Well, actually, the auto rotation pieces are part of the Consul binary itself.
Oh wow.
So if you were to just change, even without Vault involved, if you were just doing Kubernetes secrets, and you change those Kubernetes secrets, Consul would actually pick that up and rotate those TLS certificates. Same with Nomad or the ECS project. If you were to go ahead and change those, anything that is part of the reloadable configuration for Consul is now auto rotated. So that's one of the new features of Consul 1.12.
Awesome. Is there, I know, we have about 20 minutes, but you did mention a WAN Federation demo. I know it's currently not working due to forces outside of our control.
Yeah.
Would you be open to explaining a little bit of what someone could expect if they do go through the repository that we had linked? Like, what is it? What is important about the WAN Federation using Vault as a backend?
Yeah. So I can kind of describe it. I have some demo values.yaml that I could just briefly walk through and kind of explain the differences between what we just did and what would need to be enabled for WAN Federation. If that might be helpful.
Yeah.
Yeah. Okay, cool. So essentially the difference between a single data center and a federated data center is that we're going to enable the mesh gateways and federation between the clusters. And then we're also going to be exchanging some information between those clusters in the form of what used to be called a federation secret, and now is just using secrets that already exist in Vault. So what we're going to do is after we've configured Vault in the same way, we would go ahead and install Consul. And I can just kind of show you what the difference would be. This probably looks very similar to the last one, to the last installation that I showed. However, we're now using Federation enabled, and we're using a replication token instead of a Bootstrap token. This replication token is going to be shared between the primary and the secondary Consul data centers. And actually, because they both of those Consul data centers are reaching out to the same Vault cluster, they actually use the same exact secret. So this is the same text is going to be in your DC1 and DC2 values.yaml. But aside from that, we have the mesh gateways enabled, and that's pretty much the only difference. The setup between the two is a little bit more complicated, in that in order to set up the secondary data center, some of the Connect CA configuration is going to be different. So it's going to require a second auth method path. For each data center, you have to have you need to have a separate and unique auth method path. Sorry, my tongue's not working. And the reason for that is the auth method path is actually tying a bunch of JOT tokens, Kubernetes JOT tokens, into access control in Vault. And so you need to say, all right, these JOT tokens from this Kubernetes cluster are going to be used to authenticate with Vault. And these JOT tokens, which are from the service accounts in that Kubernetes cluster, these JOT tokens are going to be used to authenticate with the Vault cluster. So Vault becomes kind of your centralized piece of authentication for each of those clusters for your secrets. And so there's going to be a separate auth method path that's configured for each cluster. There's going to be a separate Connect CA configuration for each. So you have to have a separate intermediate PKI path. So they all share the same root PKI path, but they have separate intermediate PKI paths. The reason for that has to do with the DNS names that are used in the TLS certificates. So if they all use the same TLS certificates, they would have the wrong DNS names in those certificates and wouldn't be able to talk with each other. And then for your all of your secondaries, this is where you would actually set up an external Vault cluster, because in the secondary Kubernetes cluster, you would actually be providing a DNS name or a IP address of an external Vault cluster in this case. So, but that's really the main changes is just really the configuration of the Connect CA here, your auth method paths, your PKI information, and then the addition of the traditional Federation secrets that have already always existed.
Cool. And so in this setup, you have two different Vault clusters, right? So one for DC1 and one for DC2.
That's correct. It's actually, that's slightly misleading. There, in each cluster, we're going to have this Vault agent injector installed, and then we'll have one Vault server somewhere. So that Vault server cluster can be, again, it can be external to every Consul data center, or it can just be sitting with one of them. So each data center will have this injector, and this injector is going to use this auth method path to authenticate with Vault and do all of the magic to get tokens for that Consul cluster.
Got it. And in which case, then you would want, as you pointed out, you would want to separate DC1's auth method path from DC2's auth method path, and most likely, as well as the certificates. So PKI paths should also be different to a certain degree.
Yeah.
But the replication token can be, let's say, they should policy-wise, the Consul should have access to the replication. Both Consul clusters should have access to the replication token in Vault.
Yep, exactly. So they are all going to share the same gossip encryption key. They're going to share the same replication token, and they'll all reference that same secret and secret path and key.
Cool.
Yep. So it'll actually look like just a lot of duplication of logic. So I don't expect anybody to remember, but we did walk through this piece. This is the same as it was in my first demo. So there's one of these for DC1, and then there's another block for DC2. And again, the differences are that we are using these separate auth method paths to define roles. Again, all of these scripts and config.yaml files that I've been walking through right here are in that link that you provided. So you should be able to use this to demo it on your own.
Awesome. I think that's the last of it. I think we've gotten a little quiet in chat. So we'll probably wrap up a little early today. Kyle, thank you so much for going through this and for showing us all of the different secrets as well as the different ways to configure Vault as a secrets backend for Consul. First of all, this is actually really useful because I don't really want to have to rotate my own certificates. But also I tend to lose the Bootstrap. I can acknowledge this. I tend to lose the Bootstrap token on occasion. So
I have to do that all the time. I have to go find where the command is documented so that I can remember how to grab it.
Yeah. So thank you so much for going through this. For those who are tuning in, we appreciate you spending time with us, celebrating KubeCon Europe. If you are there, let us know. We have a few folks on the ground. Otherwise, we are going to have another community office hours tomorrow for Waypoint. I believe it will be at 2 p.m. Eastern, which I guess is, I think, 8 p.m. CET. And And with that, I think we'll end for today. If you would like a replay of this session, we will have it on YouTube at this same link. I'll be sure to add links to the description. With that, we hope to see you at the next community office hours. Thanks, everyone.
Thanks.